So I will talk to you about a subject that's not usually evoked in geek or developer communities or conferences. I have only 5 minutes, so I will be very fast, I hope. So I'll be talking about a country called Tunisia. I don't know how many of you know where it is. It's North Africa, and especially I'm talking about a region in Tunisia here. It's one of the poorest regions in the country. So Tunisia is one of the poor country or the global south in the world. So, sorry. And those countries are under the effects or the catastrophic effects of global warming, climate change. I don't know how are you up to date with information about climate change, but 2 days ago we passed or exceeded the 2 degrees for the first time in 200 years. So the situation is very, very catastrophic and very urgent. Sorry. And so, for example, for Tunisia, one of the countries of the global south, climate change is severely impacting the economy and the social life. So we are living, Tunisia is living one of the worst droughts in its history, which is causing a type of migration that you don't see in the news. This is not your kind of migration that you see in any mainstream media. This is the high-skilled workforce migration. This is the migration of doctors and software engineers, which is like now it's really catastrophic. I'm repeating this word catastrophic for the 3rd time, sorry. So, one of my personal convictions is that we have a debt toward the global south. Not only Tunisia, I'm talking about Tunisia because I know it, but the global south. And one of the ways in which we can help the global south is for everyone in this room or every one of us to try to compensate for these migration effects. Software engineers, they migrate from Tunisia to France, to Germany, to Canada, especially those 3 countries. It's very, believe me, from my personal experience, it's very simple to migrate if you are a Java developer, for example, or Rust developer or Go developer to France. So there is a real shortage of teachers in those areas in the global south, not only Tunisia. So what I did starting in 2021 was to cooperate with an institute, a local institute in that region, Kasrin, that I showed you. So I give remote courses, online courses to students who are really eager to learn. They are like young people, they just can't find teachers. For example, C++ course was given by a mechanics engineer. It was his first programming language. So I gave the first course. It was an introduction to Rust, and then a course on Elasticsearch. I worked with 2 groups of people, students on their final projects for BA. So one of the exploration and documentation of Raft, the consensus algorithm, and Apache Arrow in Rust, just the exploration and documentation. Again, in 2023, it was a course on Java, and I worked with 2 students on their final project about learning Rust, and we established the first Tunisia R Meetup online. So it would be great if you people can help, not only me, but you can initiate yours. So I don't have, if I have 1 minute, no? 1 minute. So just an example, for example, AWS or GCP, they give you courses. They give you $300 to start learn their cloud. In Tunisia, you don't, our credit cards, we can't use them in AWS. So even learning online, it's very difficult. It's a complicated matter. So you can help, everyone can help. Reach me if you want. Thank you. Thank you.
Turn this on. Okay. Be very quick, I guess. Yeah. Let's hope that the Mac happily sees the projector, please. Almost there. Something is happening. Okay, it does. So, okay, I just want to let you know that we're developing this. Okay, if you're interested in very large, immutable data structures, like the one at Facebook or Google, okay, an index or a shard of the web, a large part of the Facebook graph, this kind of stuff, listen, otherwise you can get back to your phone or your computer. So, no, literally, this is for this, okay? So what we needed was a way to serialize very large means like 200 gigabytes, okay, data structures that are immutable, and then you want to memory map them, because if you load them when you need to use them, the user waits 10 minutes just to read the data. So you need to memory map them and amortize the access time along the life of the data structure. Incidentally, you get also a kind of a very fast deserializing and serializing framework, but that is not our main goal. So essentially, the idea is there are a few frameworks for Rust that do zero-copy serialization. So you have a serialized object in a block of memory, and that block of memory becomes your structure, nothing else. To do that, you have to take some shortcuts. Like the main three frameworks that do that all do things that we cannot do. Like Abomination, if you know it, writes into that memory, out of question for immutable memory map structure. Archive and ZeroVec have both a cost in terms of access because they simulate relative pointers or even more complicated things. And additionally, Archive requires to re-implement all your methods by delegation on the deserialized data structure. So what Epserde does for you is that it's called Epsilon Epserde because it allocates a very small amount of memory, like the little piece on the stack, and everything else will be taken by memory mapping or directly accessing memory. And the trick we use is that whenever you have something that contains a lot of data, like a vector, on deserialization, we replace it with a reference to the memory. So what happens is that you have to work a little bit, because in your data structure, anything you want to be zero memory copy must be a parameter. So you have to add parameters with default values you actually don't need. But the advantage is that the structure you deserialize is your structure with all its method, and there is zero cost to access the memory that you memory mapped on disk. The performance is identical to a native Rust structure, which is a problem for us because we are, this comes from work from the Software Heritage Project. Anybody knows about Software Heritage, the UNESCO sponsored, okay, someone knows about that. So I'm working with INRIA, okay, they have this commit graph with 30 billion or 200 billion edges, I don't know. And they've been using for a long time our Java software for graph analysis, to do analysis, and we are moving everything to Rust. Part of this was developing a way to store certain data structure and then memory map them instantly without having to load them, and this is why we developed Epserde. There is a derived macro that will Epserde your data structure, so it's fairly easy to use. Your only cost is that whatever you want to be not actually copied, but zero copied, must be a parameter of the structure, or must be a type that is a parameter, but you can use a default type and then you don't even see it when you use the whole thing. So just to give you an idea, how many minutes do I have? One, okay. So you can see the examples, but the basic idea is that you serialize a vector like this. You have a vector. This is an array, even easier. You serialize it, but when you deserialize it, what you get is actually a reference, not an actual vector. Of course, you have to write your data structure to support this. So whenever you access your field, it must be an sref, not an actual vec, because when you deserialize, you will have a reference. But we saw there is a small amount of work to do, And you get automatically memory mapping, the serialization into memory, zero copy, and so on. So we are pretty enthusiastic about that. We're using it on a number of projects. If you're interested in this kind of stuff, large immutable memory map data structure, please have a look. Okay, thank you.